Welcome to Intro to AI, Breadth First Search with Tokyo EdTech. That is me. In today's lesson, we're going to learn how to do pathfinding using AI techniques. In this case, it's called Breadth First Search. This has numerous applications, not just in pathfinding, but in game playing and all kinds of different things. So the basic concept is search, but here we're looking at particularly how to get around a map of Romania, which is kind of interesting in and of itself. As far as coding concepts, we're going to be looking at a data structure called a queue, and we're going to be implementing that using lists in Python. So with lists, we're going to need to use the append method, we're going to be using the pop method, and we're going to need to determine if there is a particular item in a list, and you'll see how and why we're going to use that in a little bit. And then we're also going to be using objects and dot notation. So I'll get to all that later. But first, let's take a look at what breadth first search is and what does it mean. Okay, and so what I had to do here is I wanted to use this Google Docs here to help us understand what's going on. So you can see here there's a map of Romania. Now, if you're curious, why did I choose Romania? It is because of this book, Artificial Intelligence, A Modern Approach by Stuart Russell and Peter Norvig. It is, as you can see here, the authoritative, most used AI textbook probably in the world. In my grad program, this is the textbook that we use for my AI class. So my AI professor taught me this, and I'm going to teach it to you, hopefully. So that is why. So this image comes directly from that book. So breadth first search is one way of doing pathfinding. It's not necessarily going to find us the most efficient path, but it will find a path if that path exists. So in this particular case, we are starting from Arad in the west of Romania. Fun fact, I once got stuck in Arad due to a railway worker strike. I was on my way to Budapest and got as far as Arad, and I had to take a private taxi, which was a pretty wild ride. I barely survived, to be honest. Anyway, trying to get from Arad to Bucharest, which is south central Romania, and the capital, which is where I lived for a couple years. So as a human being, we can look at this map and we know, okay, well, I'm going to go to Sibiu, either Râmnicu Vâlcea, then Pitești, then Bucharest, or I can go from Sibiu to Făgăraș and then to Bucharest. So yeah, sorry, I tend to pronounce it the Romanian way. I think I'm doing it right, so sorry Romanians if I'm not. So we know that as a human being because we're looking at this map and we have all kinds of information. We know Bucharest is roughly in this direction. We know that we want to probably take a more direct path. It's going to be probably one of these two paths. But the computer can't do that. The computer doesn't have all of that information. It doesn't even really know if Bucharest exists. We're just saying, starting from Arad, how would I get to Bucharest? And the only thing that we know at Arad is that we have three possible paths. We can go to Timișoara, which is a beautiful city, by the way. We can go to Zerind, or we can go to Sibiu. Okay, so at that point, we don't know about Oradea, we don't know about Făgăraș, we don't know about any other parts of the map. We only know these three. Okay? So in breadth first search, what we do is we search all of the closest nodes. There's a little technical term for you. Each of these is called a node in our graph, which is the name for the whole thing here, this connected set of nodes. Now, this doesn't have to be a geographical map. It can be states in a game, and it'd be all the possible states. There's lots of different things we can do with this. Maybe a network map is probably a more direct thing that you can see as more of a graph rather than a tree. So anyway, Arad. So basically, I'm just going to copy this and paste that. So what we're going to do is we're going to start by looking at these three. Now, it doesn't really matter which ones we look at first, but I'm just going to do it in alphabetical order, which is going to make it a little bit easier. So I'm going to start with Sibiu, okay? And the question is, okay, so I've looked at Sibiu. Is Sibiu my goal? And it is not. Okay? So I'm going to go... And I'm going to go ahead, I'm going to go look at Timișoara. And so I'm going to take a look at that. And is Timișoara my goal of Bucharest? No, it is not. And then I'm going to look at Zerind. Okay. And I'm going to say, okay, well, is Zerind my goal? And of course it is not. Okay. So now at this point, okay, we haven't found our goal. So now we've explored all of the different nodes near Arad. We've gone one level from Arad. So now the first one we explored was CBU. Now we explore all of the nodes from CBU. So that's going to be, again, I'm going to do it in alphabetical order, but we could do it randomly. But just if we do it in alphabetical order, it makes things a little bit easier, just so we all have consistent coding. You'll see that in a bit. So Oradea. Ooh, actually, I should have done Fugarash first. Sorry. That starts with an F. So it's Fugarash. Now, is Fugarash our destination? No, it's not. Is Oradea our destination? No, it is not. And this one's a hard one to pronounce even for me. Riminchu Vilcea. Is that our destination? No, it is not. Okay. So you can see now that we've explored now one level from CBU, which gave us Fugarash, Oradea, and Riminchu Vilcea. Now I'm going to go back to Timișoara. So I'm at Timișoara. Timișoara, we've got Arad and Lugoj. Now, we've already explored Arad, so I don't need to explore it again. So that's some information I'm going to need to keep track of. So I'm going to take a look here and go over to Lugoj. And is Lugoj our destination? No, our goal? No, it's not. So now I'm going to go back to Zerind. And I'm going to say Zerind has Arad and Oradea, but they've both already been explored. Okay, so I don't need to worry about them anymore at this point for now. So now I've explored one level deep from the first level. So here was my first level. Here, actually, maybe I should use a different color for my second level. Maybe that'll make life a little easier for us. So let's change that color to... Now, if you're just interested in the coding, you can kind of jump ahead to a different section here. So let's make those lighter. Okay. I don't know if that really helped. Let's try and use a different color. Let's use... let's go ahead and do this one. Okay. There's our second level. So now I'm going to go ahead and I'm going to search again from the next level. And again, so I looked at Fugarash first, and you'll see how we're going to do this in coding. So I'm going to, from Fugarash, I want to go one level. Now I've got CBU, which I've already explored. And then I've got, actually, I'm going to look at Bucharest, okay, which is actually my goal. I've found my goal, and now I know that my path is Bucharest, Fugarash, CBU, and Arad. Okay, so that is how breadth first search works. We go like level 1, then we go level 2, then we go level 3, and then so on and so forth from each of those nodes. So in this case, that is kind of the order that we explored everything. As I mentioned, Bucharest is our goal, and we are happy. Okay, so that's basically how breadth first search works. Okay, just as a high level demonstration of what it looks like. So the thing that we want to look at now is the actual algorithm to do this. Okay, so this is I got this from Wikipedia. So you can see this is an algorithm. So this is the step-by-step instructions of how to do breadth first search. Notice it's not an actual programming language. It's in what's called pseudocode. So I can take this pseudocode and I can implement this in Python, which we're going to do. I can implement it in Java. I can do it in JavaScript. It doesn't really matter which language. So the algorithm itself is language agnostic. It doesn't really specify a language. It's specifying a process. So it starts with a procedure, and G in this case means graph. So we have a graph of Romania. The root is our starting point. Now this doesn't mention goal. Some of it you have to like really think about, well, how would I actually code this? I'm going to show you that process in a minute. So it says let Q be a queue. Okay, so what is a queue? Okay, so if you're British, you probably know this, but if you're American, you might not know this one. A queue is just a line. So if you go to McDonald's, I actually had McDonald's for dinner tonight. So I go to McDonald's, I'm at the front of the line. Somebody comes in, they're behind me. Somebody goes in behind. So the first person there, in this case me, is the first person to make their order. So this is why we call this first in, first out. So that's what a queue is. It's pretty straightforward. So the second part, the third line here says label route as explored. So what we're keeping track of here is, did we already explore Zerend? Did we already explore Oradea? If we've explored it, we've already been there. We don't need to explore it again. So that means we have to keep track of, where we've explored so far. Now it says while the queue is not empty, so while there are still nodes to explore, v equals, or is equivalent to, queue.dq. And so what that means is to take the first node from the queue. So my McDonald's example, the cashier says, can I take your order? And because I'm first, I'm going to go first. So we take that out of the queue. And then we check, is that our goal? If we found our goal, awesome, we are done. Okay. And then if it's not the goal, it says for all edges from V to W in G dot adjacent edges V. Now, I really don't like this mathematical language, to be perfectly honest. I wish they could write this a little bit, more human friendly. If you read that Norvig, the Norvig book, Stuart Norvig book, I should say, you'll see a lot of this kind of stuff. It's very, but once you get used to it, it's not so bad. So edges from V to W in G dot adjacent edges. That's a fancy way of saying, so this path here from Arad to Zerend is an edge. From Arad to Sibiu, this is an edge. And from Arad to Timișoara, this is an edge. So there, for each edge, so this is what we did. So we started with Sibiu, then we looked at Timișoara, then we looked at Zerend. Okay, so we're going to go through each of these nodes. And again, we're going to do it in alphabetical order just so our code looks the same. You don't have to do it that way. Sometimes you get lucky and you explore fewer nodes. Sometimes you don't get lucky and you explore more, but we're just going to do it in alphabetical order. So if that edge, or if that node, I should say, is not explored already. Okay, so if we haven't explored Oradea, we explore it. If we have explored it, we just skip it. We don't do anything with it. Okay, so then if it's not explored, then now we add it to the explored. We're going to keep track of what's explored. We say that its parent is the node it came from. So what that means is, I'll use the path that we found. So when I explore Sibiu, where did I come from? I came from Arad. So Arad is the parent. When I explored Făgăraș, the parent is Sibiu. When I explored Bucharest, the parent is Făgăraș. So that's how I'm going to know the path. So the parent of Bucharest is Făgăraș, the parent of Făgăraș is Sibiu, the parent of Sibiu is Arad. And then once I've done that, I'm going to enqueue. I'm going to add that to the queue. Now I'm going to come back, take the next item off of the queue, and go from there. Okay, so that's the algorithm. That's what it means kind of in English. Okay, so let's go ahead and try to turn this into some code. Now, you're going to need to go to my GitHub, and I'll put the link, in the comments down below. In my GitHub, you'll see, let's see, I'll just go from the top. So it is Winan1004, and you'll see projects. This is where I put all my kind of stuff for this my YouTube channel, and you see all kinds of stuff here. You're going to go down to search, okay? And there are two files. There's romania.py, and you can open that up, and there is search.py. So basically, I'm just going to download. I've already done it, so you're just going to download the raw file. Make sure they're in a folder together. Okay, so that's going to be very helpful. And so on my computer, I've already done that, and I've opened up each file in Genie, which is my preferred IDE. So you can see in the romania.py file, we have a class called node. If you're not sure what a class is, don't really worry about it. A node is just an object that has some properties. And I've kept this as simple as humanly possible for my students. I teach an AI course to high school students, and I have some really awesome students. We just did this lesson actually this past week, and they killed it. I was very proud of them. So each of our nodes, so each of our in this case, a node represents a city. It has a name. We also have we're keeping track of distance to Bucharest. Now that won't matter in breadth first search, but if we get to A star, it will matter. There's other types of search. The edges are the different cities that are connected. The weights are the weights, the distance in kilometers. So from one city to another. It's not going to matter in breadth first search, but it will matter if we do, like say, Dijkstra's algorithm, for example. And then we also have to keep track of the parent. So what city did we come to get here? Okay, so you can see Arad is 366 kilometers from Bucharest. Bucharest is 0 kilometers from Bucharest, and so on and so forth. And so we looked at Arad. So Arad has 3 edges, Sibiu, Timișoara, and Zerind. And from Arad to Sibiu, it's 140 kilometers. From Arad to Timișoara, it's 118. And from Arad to Zerind, it is 75. Now, again, we won't be using this information in this particular video, but it's there later should we need it. And then we will be using this information for sure. So in the search.py file, so if I run this right now, I don't think it does anything. Yeah, it just says Bucharest. So I have a method here called show path. Well, first, actually, I import this file. So you'll see it says from Romania. So that's romania.py. That's why they have to be in the same folder. Import everything. And it imports it into what's called this namespace. So it's essentially the same as if I copied and pasted this right here. It's the exact same thing, but it allows me to organize it into separate files. I have a method called show path. So at the end of this, we're going to do show path and Bucharest, and that's going to give us the path that we found from Arad, in this case, to Bucharest. And then in this video, we're going to be looking at breadth first search. But there's also depth first search, which I'll hopefully get to in the next video. So you can see we have a start node. In this case, it's Arad. So you can change that. You can play around with this. We have a goal, which is Bucharest. And then in this case, we're going to do breadth first search. And then once that's done, we will show the path. Again, the organization of this maybe isn't the best. I probably could have done a little better with this, but it's simple enough, again, that my students can understand it. It's pretty appropriate to their level. So anyway, we're going to be looking at breadth first search. Let me pull this over a little bit this way, and I'm going to go ahead and pull this over this way. And hopefully you can see both of those things pretty well. And see if I can make that bigger. No, I don't want the full screen. Exit full screen. All right, so hopefully you can see that, and I'm going to code it line for line over here. Okay, so it says let Q be a queue. Now I could actually, I can import the queue thing. Okay, I know people are more experienced, but what we're gonna do is we're gonna use a list to simulate a queue. All right, so I'm gonna go Q equals square brackets. So that gives me an empty list. Okay, it says label route as explored. So what I could have done is I could have put self.explored equals, false here. And then I could have done it through the node, but I'm going to do it. I'm going to use another list to do that. Okay, which kind of makes things easier, I think, especially for beginners. So I'm going to make a little list called explored. Okay, and that's where we're going to keep track of that information. So the queue is, what we have left to explore. Explored is what we've already explored. And it says here Q and Q root. Okay, so in this case, root is the starting point. So what I'm going to do is I'm going to do start. It's going to go here. It says label root as explored. So I'm going to put start in both the queue and in explored. So the next line says while queue is not empty. So in Python, I could do it like this. I say while the length of the queue is not equal to 0. Now I could have done greater than 0 or whatever, but I think this more closely aligns with the language here. So while the length of the queue is not 0, so while we have something in the queue, do this. So it says v equals q.dq. So I'm going to go node equals queuee dot pop 0. What that does is it will pop the first item off the queue. Okay. So eventually we're going to have, our queue is going to look like start, then it's going to go to CBU, Timmy, Sowara, and zend. Okay. So eventually it's going to go like that. So what we want to do is we want to pop this off because we're going in alphabetical order. Okay. So pop 0 will pop the 0th item, which is the first item on the list. So that gives us a node for us to explore. Alrighty, what does it say here? Now, if v is the goal, then return v. So what I'm going to do is I'm going to say if v is the goal. So if node equals goal. Now it says return v. I'm just going to go ahead and I'm just going to break, and that will, get me out of the loop, and it will end the function. Okay, but I could do return v if I wanted. I could do return node, but we're not really using that. Let's try it. Let's do return node. Try it that way. Okay, now if it's not the goal, if it is not the goal, for all edges from v to w in g.adjacent edges v do. Okay, so what we need to do is go through all of the edges of that node. So if you remember over here, each node has a set of edges. Okay, and you can see down here for Arad, the edges equal CBU, Timișoara, and zend, just as we did earlier. So for edge in node.edges. Okay. So this is what we mean by dot notation. So Arad.edges. Okay, so for each of these nodes, CBU, Timișoara, and zend, it says if W is labeled as not explored. So we have to find out, have we already explored it, yes or no? So if edge not in explored. So if the edge is not in explored, that edge node, I don't see how we say that there. If it's not, it says label W as explored. So what we do is we explored.append edge. So I've added it to this explored list. That's how we're keeping track of what's been explored. It says w.parent is equivalent to v. So I'm going to say the parent, so edge.parent. So again, going back to here, the parent is the node that we just came from. Okay, so the first one, so the start is Arad. So node equals q.pop0. That's going to be the node is Arad. If Arad equals Bucharest, return Arad. For each edge in Arad.edges, if that edge is not explored, add it to explored. And then its parent is the node. So the edge, so CBU.parent is Arad, Timișoara.parent is Arad, and zend.parent is Arad. And then the last line, it says NQ W. So I'm going to do QUEUE.append edge. And that is the entire algorithm written in Python. Now let's see if it works. Okay, I'm going to go ahead. I ran it. I have an indentation error. Okay, line 25. What did I do here? Okay. All right. So this is a tab, and I need to use spaces. 2, 3, 4. Depends how your editor is set up. You might have the same problem. So I'm going to go ahead and run this again, and you can see Arad to Sibiu to Făgăraș to Bucharest. So that has given us the exact path that we expected. So if I go back to here, that gives us Arad, Sibiu, Fogaras, and Bucharest. So we can see our breadth first search is working as we expect. So let's go ahead and just have a little fun. Let's try a couple other cities. So instead of Arad, let's try and pick some places I've been. Let's say I'm in Sibiu, and I want to go to Iași. Also, Iași is a lovely little town. Iași. Been there several times. Been to Sibiu a couple times as well. That's nice. If you ever get a chance, I recommend visiting. So looking at the map, so from Sibiu to Iași, we're probably going to go Fogaras, Bucharest, Urziceni, Vaslui, and Iași. Let's see what it comes up with. Okay, so Sibiu, Fogaras, Bucharest, Urziceni, Vaslui, Iași. Okay, so I think it's working pretty well. Let's try Timișoara. And run that again. I spelled it wrong. Timișoara. And sorry. Let's do it one more time. And so Timișoara to Arad, to Sibiu, to Fogaras, to Bucharest, to Urziceni, to Vaslui, to Iași. So you can see now we are able to find a path. And this is a simple map, so it runs very, very quickly, which is nice. But that is the gist of breadth first search. Okay. So just kind of real quick to go back. If I can make this bigger here. Get this out of full screen. Actually, let's do slideshow. So again, just to remind you how breadth first search works, we have a starting point and we have a goal. We go to the start and we look at all of the nodes that are one level down from that node. We check, are they the goal? Okay. Then we go, if that's not the goal, then we go to the first one we checked. We check all of the nodes that are connected to that. Okay. Then we check the nodes to Timișoara, that one. So it's level 1. So like let's say this is level 0, check all the nodes here. Then we check all the connected nodes here. Then we check all the connected nodes here. So it's kind of like it circles out. You know, it's wider and wider and wider until we find our goal. So I think that's it. Again, Q real quick is a first in, first out data structure. In our case, we use a list to simulate that. And we just basically figure out how to find a path from any 2 points on a connected graph. So I hope that made sense. And like I always like to say, keep on coding. Thanks for watching. And if you liked it, please subscribe.